There is a distinct line in software engineering where an AI stops acting like a simple text utility and sparks into something that feels alive. That evolutionary leap is the primary objective of V.C.A.I. This rebuild aimed to transform a standard text-heavy interface into a highly responsive, voice-driven conversational partner, an experience inspired by the advanced AI systems of science fiction. Creating a convincing sense of presence is an engineering challenge. A polished interface remains ineffective without an underlying architecture built to sustain the speed of real-time interaction. The original project relied on a standard HTML foundation. This architecture was designed for retrieving static documents, making it ill-suited for the demands of a thinking machine. This structure created a flaw in state management. The system dropped data payloads between requests and lost its context. That structural bottleneck forced full-page updates. The resulting latency injected awkward delays, breaking the illusion of a natural conversation. You cannot patch a static framework to achieve real-time fluidity. To eliminate that friction, the entire foundation had to be replaced. The replacement foundation is a modern React architecture. With a component-based structure, isolated parts of the interface update independently. The system no longer refreshes the entire application for every user input. Paired with global state management, a unified memory network runs through every component, keeping the AI's context synchronized during navigation. By handling memory internally, the front-end drastically reduces processing delay, rendering incoming data the millisecond it arrives. The interface now functions as a reactive nervous system, capable of immediate reflexes. A fast reflex needs a fast brain. Beneath the React interface lies the cognitive layer, a newly optimized Python server designed for heavy computational lifting. This pipeline maps a user prompt. A request originates at the React client, routes through the Python layer, and hits the AI engine. The critical upgrade is streaming response support. Instead of waiting, the server feeds text back to the user word by word. This continuous delivery enables accurate interruption handling. If a user speaks over the AI, the stream halts immediately, capturing the natural give and take of a human conversation. The backend evolution has turned an exchange of rigid data packets into a flowing dialogue. With latency erased and data streaming freely, the architecture could finally support a dedicated, real-time voice mode. This mode features a futuristic interface. At its center sits a reactive AI orb, serving as the visual anchor for the intelligence on the other end of the line. Accessing it requires a one-time microphone permission. Once approved, the user simply speaks without clicking additional buttons. Spoken responses are driven by a unified text-to-speech engine. By centralizing the voice architecture, the user's selected audio settings remain locked in, ensuring the AI maintains a consistent identity across the platform. The pulsing orb is the precise visual manifestation of a fully integrated zero-latency cognitive loop, reacting to raw data in real time. Because of that centralized state, jumping between standard text chat and the immersive voice mode happens without losing user preferences. This relies on live voice synchronization. The auditory speech output and the visual text in the React UI pull from the same streaming data simultaneously. A truly advanced system is defined by the complete elimination of friction between the human and the machine layers. By replacing a rigid HTML foundation with a scalable real-time architecture, this project cleared the bottlenecks that once limited its potential. What remains is a highly responsive, immersive application that operates effortlessly at full capacity. V.C.A.I. now functions as a unified, reactive environment for the next generation of AI interaction.